guys, so I just kind of really want to go over how to set up a notebook for the class. So when I'm doing PowerPoints, how to keep all your notes organized, because that's something we kind of forget how to do. So I just have a simple composition notebook, and I'm going to label this Chem 101 with Mrs. Valdivia, and we are in, what is it, spring 2023. Okay. Okay. So this first page, I kind of just like to make it, some people might call it my throwaway page, but usually classes are divided into semesters, and I would like to write semester 1, semester 2, or if you're going to take general chemistry later on and you don't write that big, you might want to write like Chem 10 on this one. And so when you get towards the middle and you're ready to start maybe your general Chem 24A, you could have Chem 24A, Chem 24B, or you just want to make it a nice page. So I usually make this my nice page. I tend to decorate it and whatnot, but for time's sakes, I'm just going to write Chem 10. And I like to put down any kind of personal information that we might have for the class on here. So if you know your section number that you're in or anything, then you could go ahead and put your section number down. So I think we are, did I write my section number down? Okay, I didn't write the section number down. So go ahead and write your section number down. We are asynchronous course. So we don't meet in person, right? So we're all online, and you could write spring 2023, and then your name, so put your name down. So in case it ever gets lost, it could get returned to you. Right. This page right here is my table of contents. Now, when I set up notebooks, I like to set up my notebooks based on assignment number and not page number. Okay. So I'm going to just add a line here. Okay, and I'm going to have assignment number. So I'm just going to write the number here, and then over here I'm just going to write title. And if you like, you could put down the date or anything like that you want. Usually that's if you're meeting in person. You could put down things like, is this lecture or lab? If you're going to take your notes on both of these, like both lecture and lab on the notebook, you put down, is this lecture or is this lab? And so So for assignment number 1, this is going to be chapter 1, foundations. All right, that's done. And like I said, just put a line underneath it, and this is lecture. You could then continue on with your things. So assignment number 1. So now let's get going on assignment number 1. Right up here in the corner, I'm going to put a giant 1. And every page that I utilize for this is going to have a number 1 on it. So chapter 1, foundations. Okay. And in this case, I'm just going to keep everything simple since we already made a PowerPoint video to help guide you guys with this. This is going to be more like our vocabulary and key things like that to add. So this first one, we have the word matter. Okay, and what is matter? The study of anything that takes up volume. And since we talked about volume, what is volume? Volume is the amount of space something takes up. So let's have a little bit of examples, right? Because why not? Sorry, I love to change uh, my colors all the time. Okay, so my examples. That's closer to me here. You could have solid. Let me use this color. So examples of solids are like a table, right? A pen, any kind of metal, right? Then we have examples of liquids that are matter, anything that's matter, right? Actually, a solid, we could put humans like us, you, me, right? So an example of liquids, we could have milk, water, solutions, um, pee, if you want to write that down. And solids, liquids. Let's look, see if we have gases. Example of gases are helium, we have hydrogen gas, okay, carbon dioxide, stuff we breathe out, right? Okay. So how do we describe matter? How is matter described? So it is just described of what it is made from. So proteins versus lipids or fats. I'm going to just write lipids. And based on our PowerPoint, we know that what something is made from, that's known as composition. So this is our composition. Guess I should have wrote that up here. Composition, what something is made from. Okay. And then the next one is, how is it arranged? All right. So in this case, like, is it um, is it melted? Is it a solid? Right? Like gold. Is it a gold bar or is it melted gold? So let's write melted versus solid. And this is called the structure. And then if we recall, we have pure substances. And pure substances can be in two forms, right? We can have the elemental form, or we can have a compound like a molecule, right? So we have elemental form, and an element means only one type of atom. So an example would be gold, right? Maybe hydrogen. Okay. So let's figure out, well, what is an atom? Let's use this color here. An atom is the fundamental units of matter. And atoms make up everything. So if atoms make up anything, don't trust an atom. So that's just a little joke for you guys right there. Just in case someone doesn't have the volume on. Joke! All right. And we also have compounds. And compounds are composed of more than one atom. Actually, that's the wrong word. Composed of more than one element. And they have fixed ratios. So our example that we used was water, H2O, right? And you had two water molecules connected to one giant oxygen molecule, right? So it's two hydrogens to one oxygen. All right, now that we're done with that page, since we're still on chapter 1, assignment number 1, I'm going to put that there, and I'm going to rewrite the title. Now remember, I'm mainly doing this one for chapter 1 so you guys could learn how to take some notes, right, on some of the key things that we went over. You don't have to write everything down. So everything that was covered or said, you just want the key points, okay? Just the key points. Okay. So let's see. Let's go over mixtures. Mixtures are no fixed ratios. They're different from compounds. They have no fixed ratios. They're chemically bonded together. And mixtures can be homogeneous. And homogeneous, if we recall, means that they are the same composition. Throughout. Okay. And the examples that we used was air, and coffee. We could also have a heterogeneous mixture. And heterogeneous means having different composition throughout. You could separate it. So sand in water was one of those examples that we did, and a precipitate. So something that forms inside of water. Or pulp inside of orange juice. That's another one that you see in regular life. Oh, what you guys see me doing is I already took all my notes ahead of time, and I am rewriting them for you guys. I should have done it the first time, but I didn't think of it. So I'm rewriting them. Less sloppy anyways. All right, so now that we've done this, the next thing we talked about in the PowerPoint were the 3 states of matter. Right? And if you guys recall, the 3 states of matter that we have are solids, we have liquids, and gas. And our solids have a definite shape, and a definite volume. They are more dense than water, and they're not as compressible, or they're non-compressible. Our liquids, on the other hand, have an indefinite shape. They have a definite volume, which means the amount you have doesn't change. They are less dense than a solid. And liquids are not compressible. If you try to compress them, they will just change their shape that they have. And finally, gas. So a gas has an indefinite shape, an indefinite volume. It's the least dense out of them all. And it is compressible. You can compress a gas, and that is because there is a lot of space between the molecules of the gas. Okay? So what do each one of these look like in a molecular level? Let's find out. So I'm going to make 3 little circles here. Separate those there. All right, so if I have a solid, if we recall, solids are nicely packed together. They have a definite shape. They have a definite volume. They are arranged in a very organized fashion. The ones I'm showing here are shown as a 1:1 ratio, not to scale. Okay. Now let's look at a water molecule and how that one is different from this one. So a water molecule its molecules are moving around. Sometimes they overlap each other. But as you can see, there is no definite shape to these. It's kind of a jumbled up mess of some sort. That's why we're able to get waves inside of the ocean. Right? So a little jumbled up mess, not organized. So the last one we have is going to be gas molecules. And gas molecules are free to move and they like to stay away from each other. So all of these little circles, they represent atoms. These have fixed patterns, organized. These ones right here, no fixed pattern. But the atoms are still touching. So atoms are touching. I mean, they're touching here as well, but they're just moving around. So it's a little bit, I'm going to call this a little bit more chaotic. And finally, we have the gas, and the gas is random motion. So just random, right? So the molecules are moving. And you'll notice that the atoms are not touching. Okay. So those represent our 3 states of matter. Also, you guys notice I don't write on the back of my pages. So I usually leave these for when I'm working out problems, when I have homework to do or questions that I need to answer and I need something to write it with. I like to do it with my notes page. So that way I could reference my pages. I could write questions here that I might have and write it. So leave that back open and available to you. All right. We also talked about the changes of state. And this is also known as AKA phase changes. And if I had time, I would draw a lot of little funny things here, but there is no time. All right, here we go. We have a line here, and this line is going to represent our temperature. Okay, and the arrow means that air temperature is increasing. Okay, so at the bottom, I'm going to show a solid. So I'm going to write solid. Okay, and I'm just going to have a little solid block here. And if we remember, they are slightly vibrating. Okay. On the top, I'm going to have a liquid. Molecules are moving about. They're moving a lot more. Okay. And on the top, I'm going to have a gas. All right. And molecules are kind of floating around and whatnot. All right. Now I know that I can go from a solid to a liquid to a gas. Okay. And to go from a solid to a liquid, this state is called melting. And to go from a liquid to a gas, it's called vaporization or evaporation. I'm just going to evaporate. All right. And we can have the reverse also occur. We can go from our gas to a liquid. And when we go from a gas to a liquid, that's called condensation. And we can go from a liquid to a solid. That is called freezing. And one big one here is we can actually go from solid to a gas. So if we went from a solid straight to a gas, right there, that is called sublimation. And if we went from the gas to a solid, let's see, where do I want to write this? Make sure we can see these. This one right here is called deposition. So those are our phase changes for our states of matter. All right, next thing is physical or chemical properties. So physical properties can be measured without, so keyword here, without changing the identity of the substance. All right. And then one very, very important thing is that all phase changes are physical changes. Chemical properties. The identity the original identity of a substance changes or has changed. Okay. That means you can no longer get that same thing. All chemical reactions I'm going to put RxNS for reactions are chemical changes, like the burning of wood. Alright, let's finish up with some energy, right? So, energy is the ability to do work. Okay. Molecules or compounds. Compounds have a lot of energy inside of them, a lot. And they turn into new compounds usually because they want to stabilize, they want to lose that energy that's inside of them. So if you have energy inside of you, right, you're storing it. That energy is known as potential energy, which is stored energy. So stored energy. And it's just waiting to be released. And we have kinetic. And kinetic energy is energy in motion. Okay. And the way that energy moves, I was going to try to squeeze it all in there, but I got paper. The way that energy moves, so this is energy continued. Is exothermic and endothermic. So remember, exo means exit, endo means enter, right? And so exothermic reactions, you are releasing heat. And endothermic reactions, you are absorbing heat. Okay, so releasing heat, absorbing heat, releasing heat, absorbing heat. You're taking it in, right? Okay, you guys. So hopefully this was a nice little thing. I'm not going to do it for all the chapters, just for chapter 1, to help you see how I've taken notes in the past. And like I said, I like to write questions and things like that here, and I'll show you guys that in a different PowerPoint when I go through some questions and put them down on here using my notebook as my guide. It's kind of making my own little textbook. If you guys do that throughout the semester, or the course. It's going to really, really help you, especially when you need to access your information fast and quickly for a quiz or an exam. All right, bye.